Hello and welcome to Learn C++ in an easy way. In the first project, we are going to count the digits of a number. So let us start. We are going to ask the user to enter a number. So we just print that, okay, enter number, see out, enter an integer number, and then we are going to take it, so we define integer n, we take it using scene, see the video in the caption. Now we should have an algorithm for counting digits, right? Let us look at, for example, number 56. If we divide it by 10, then because we are working with integer numbers, the result is 5. However, 56 dividing by 100 is 0, right? And simply because we are working with integers. And this is telling me that the number of digits of 56 is 2, right? So another example, the number which is of 4 digits, if I divide it by 1000, yeah, 1000 also has 4 digits, then the result is 6, the first digit. And however, if I divide it by 10,000, then the result is 0. So now we can guess how the algorithm should be, and we want to use while. So we write while here and parentheses and then brackets. Yeah. So inside the brackets, I want to use integer I, so I write here int I equal to 1. We start with I equal to 1, and we define integer s to be n over 10 to I, right? So we are using a power of 10 and I. We should have CMAT, so I go to the first lines to see if I have this package there. If not, I use this header. So I just copy and paste this one here and change this one to sim. Yeah, perfect. So now we can correctly use pub. And now, so this is exactly similar to the rule that we are doing in the above. And we should decide if this is 0 or not, right? So if our s is equal to 0, this is time to decide about the number of digits. That means I should stop while loop, so I define boolean p equal to true, and if s is equal to 0, then I change p, right, from true to false. So p equal to false. So the loop continue as long as p is true, and if s is not equal to 0, continue please, and add I with 1, so increase I 1 degree, and the loops continue. For example, we can look at our example 56. 6, I is equal to 1, P is true, loop starts, and so 56 divided by 10, because I is 1, is non-zero, so it changes to 2, so I is 2. Now 56 divided by 100 is 0, stops everything, and so our I is actually the number of digits, right? So your number has exactly I digits, right? So now we are done. It's time to test it. So I run the program. Here I write, for example, a number with 4 digits, and your number has 4 digits. I just write in a space here to have everything nicely. So I write, for example, a number with 9 digits, right? So let us see. Perfect. Now we go to the next project. In this project, we take an integer number and we calculate what is the sum of its digit. Let's go. So we continue with the previous project, right? Because we already took an integer number and we wrote a program that using that we can understand how many digits our number n has, right? So I is our number of digits. So now I want to use another while loop that at the end it gives me that sum of um, digits of your number is equal to something which is sum, right? So we are going to define an integer sum, and now is 0, but during a while loop you are going to change it, right? So now we write our while. So we have while parentheses here, and now to understand our while loop, let us look at this number 56. What is 5 here and what is 6 here? So to obtain 5, it's enough that I looked at our I here is 2. That means the number of digits, right? So if I divide 56 by 10, which has 2 digits, then the result is 5. So we got to 5. Now, what is 6? 6 is actually equal to 56 minus 50, right? That 50 is 5 times 10. So another example. For example, this number which has 3 digits, so our I is equal to 3. To obtain 3, it's enough that we divide our number by 100, right? So, and 100 has also 3 digits. Now to obtain 4, at first we get 45, then 45 is actually equal to 345 minus 3 times 100, right? Then we have 45, and then we do the same, and 45 divided by 10 is equal to 4. That means we obtain two other digit of our number, and finally 5 is just 45 minus 40, and then we are done, right? Also 5 divided by 1 is equal to 5. So I think the rule and the algorithm is clear now. I just write here 5 is equal to 5 over 1 to make things more clear. So what I do, um, I define integer k to be n over power of, so here power of 10 and minus I, because I was the number of our um, digits. And if you look at the above example, we see that we should decrease it 1. Yeah, so we add simply k to our sum. And now we change our n for the start of our loop, and we write n minus k times power of 10 and I, because I has changed already, right? So it should be done only by a semicolon here, and then yeah. So but when the loop stops, when I uh, is negative, so the loop continues as long as I is equal to 0, right? Now it's time to test it. I write 56 and sum of your digit is 11. And this is true. And your number has 2 digits, sum of the elements is 11. And if here I write, okay, your number n has 5 digits, it works well because till now n hasn't changed, right? But here during the second loop n is changing, right? So it's wrong if here I write some digits of your sum of digits of your number n is equal to sum. This is wrong, right? Uh, we can test it, but this is wrong because n has changed and this is not going to give us our real number. Actually, n at this stage is 0. I also corrected this line. So, for example, if I run it and I write 56, you see it's 0. Our n here is 0, but however here is 56. So this n is wrong to write here. One way to fix it is this, that we don't use n in our second while loop, right? So simply here, for example, I write integer m equal to n, then I work with m during my while, right? So everywhere instead of n, I write m. So our first n hasn't changed. Now, if I run it, so I write 56, and yes, everywhere is written 56, right? So your number 56 has 2 digits. Sum of the digits of your number 56 is 11. Perfect.